record and then share screen. Okay, so I'm going to start with whiteboard first. Last 2 weeks, is it? Last couple of weeks anyway. We discussed data structure. A new data structure, a lot of time we also call it ADT. If you see this in CS field, okay, it's called abstract data type. That means some data structure, okay. And we learned a new one called stack, is it? And stack's feature, we said the four letter is the LIFO, is it? Last in and first out. Okay, and we also discussed a couple of applications with stack, is it? So stack is pretty good at reversing, is it? If you want to reversing something, is it? Reversing. And we also discussed like number conversion, is it? Number conversion. And we also discussed infix, postfix, and infix to postfix, is it? And we also discussed the runtime stack. So now you understand that, is it? And we didn't get a chance to go over any of that example for step, but there is a large use with stack is backtracking. Like when you write some game, is it maze game, and you want to backtracking, is it? And the stack is a good data structure to store all of your internal turning points, okay? So there are a lot of other applications we can do with the stack, okay? And when we discuss the stack, we also discussed the way we implemented using array, is it? And we also discussed the generic stack in collection, okay? So collection frameworks is a stack. Okay, that's just a regarding stack. And then we learn recursion, is it? And something related with stack regarding recursion is versus iterative, is it iteration? And we mentioned, we discussed a number of examples about recursion. Recursion is necessary, is it? Is necessary, even though its efficiency is not as good as iterative, is it? And who remember what's the reason for that? Why it's not as efficient as the iterative way? If you have a task, you can complete it in either iterative way or recursive way. Then definitely iterative way is better, it's more efficient. It's why it's because recursion has method call overhead, is it? Oh, I see something, let me see the chat, is it? Oh, attendance, okay. Okay, so has a function method call overhead because of recursion, but it is necessary, is it? Because some task you cannot solve it with just iterative way. You need to use a recursive idea, the concept to solve it. Okay, so that's related with stack. So anyway, stack is a data structure that we learned, can be used to store a collection of items, and it's last in, first out, and you can only access at top, is it? So that's what we learn. So today we will learn a new data structure. We call it Queue. And we all are quite familiar with this concept, is it? And if you recall, you go to grocery shopping, is it? And when you do checkout, is it grocery checkout lane? Checkout lane, is it? So it's grocery, is it checkout lane? And whoever is the first to come will be at the top, at the beginning of the line, is it? At the front, is it? And then the second one needed to follow the first, is it? And then the third one, is it? And who is the last one going to be at the back, is it? Is it? And when you do, so that's how you join the line, is it? But when I want to leave the line, is it? When I do checkout, is it? So whoever is at the front get to check out first, is it? Check out first, is it? Check out first, okay. So so in this case, with regarding the checkout lane, is it? So you have two ends, is it? Front end, is it? And we also have back end, is it? And both end opens. Is it not like versus stack? Stack is only top open, is it? So that's different. Is that you can only access at top, but for for grocery checkout lane, the line, is it? You can access both ends, is it? So can access both ends, is it? And this kind of like the line, is it? Any kind of line, or like the checkout lane, is it? This kind of thing, we call it Queue. And for Queue, you can access at both ends. Okay, we can access, but be careful is, generally speaking, when we discuss the data structure, what we care a lot is about adding and removing. Is it adding and removing? So for Queue, when we do add, we add at where? At front or at back? We add at front. Oh, no. We add at back. Is it? When we do remove, you check out. Is it you're going to leave the line? When we do remove, we remove at where? At front. Is it? So you add at back, but you remove at front, is it? So if you recall, and this is so this compare with stack. Stack is you reverse the order, is it? So it's last in, first out. But for Queue, then it's different, is it? It's keep the order. Is it? The order. What's the order? If you are going to be the first in, coming in, is it? You will be the first out. Is it? First out. So we say it's FIFO instead of LIFO. Okay, so it's first in, first out. Okay, first in, first out. That's a Queue's feature. Okay, so Queue, generally speaking, then its feature, regarding a queue is first in, first out. Okay, first in, first out. And you can access at both ends. Okay, and here we mean front and back. Okay, and back. And we keep order. Is it keep the original order? Regional order, is it? So this is the general concept regarding queue, okay, regarding queue. So it's a new data structure, okay, and it's used to store a collection of items, okay, and when you store this collection of items, you keep the original joining order. That what's the order? It's first in, first out. Okay, and when you want to do adding, so adding can only be add at back. Okay, and when you do remove, you can only remove at front. Okay, so that's the difference between a queue and the stack data structure. Okay, and then next let's think about how do we implement a queue. Okay, so how do we implement a queue ADT? Is it so just like a stack? Is it so? Here we will first start with array also. Okay, we are going to use an array to implement a queue. Okay, and then next let's think about what kind of information we need to use to represent a queue using an array. Is it? So let's see. Suppose our queue size. So the queue capacity is 6. Okay, assuming it's 6. So then we are going to use an array that, okay, 1, 2, 3, 4, 5, 6. Okay, and here's the sub 0, sub 1 arrays index, and sub 2, sub 3, sub 4, and sub 5. Okay, so we have there are no other colors. Maybe I tried this color. Okay, and then let's see. So then in this case, is it suppose I have a number 70 I want to add to the queue. Is it, so I'm going to use this array. Okay, so this is array. Is it, and I'm going to use this array, try to store all the items for the queue. Is it? So I have 70, then obviously we can put 70 in the first slot. Is it? And then next I'm going to add 80. Is it? Okay. So 80 going to go to next. Is it? And then 90. Is it? I'm going to add 90. And then 100. Okay. I'm going to add 100. Is it? And then next, I'm going to 110. Okay, I'm going to add 110. Okay, and generally speaking, when we implement a queue, we don't use the full capacity of the queue to store all of the items. Okay, we leave one slot empty. Okay, one slot empty. Okay, then let's see. But then you may ask, how do I keep track? Know where is the front, where is the back of the queue? Is it for stack? You remember when we implement stack, then the first element you add, is it? And we use that top index to keep track of index. Is it? So here, similar idea, we needed to use some index number to keep track of where the front is, where the back is it? Okay, so obviously in this scenario now, 70 is front, is it? But I want to keep track of where the front is it? So I need an index. I call it M front, is it? Then in this case, M front is at sub 0, is it? The first slot of this array, is it? Okay, and then, and for our queue implementation, initially, is it, because we also need to keep track of where the last item is it? So I need another index. I call it M back, okay? So then the case is where M back is it? So M back, is it? And when your queue is empty, so here is the queue, is it? When the queue is empty, both M front and M back, you set both at 0, okay? So M back in this case is 0, is it? M front is 0, and then I add 70. Is it? I add 70 to this queue. Okay, 70 to this queue, and 70 is at where? Is at M, is at the sub 0 location, is it? But then how do I keep track of the back, is it? So in queue implementation, then we will advance back to the next empty one. Okay, so be careful. So the back index is set to the slot right after the last item. So it's the empty slot, okay? It's not the last item one. Okay, so then in this case, M back should be updated to 1, is it? So M back is going to be updated to 1. Okay, and the front still point to 70. Okay, point to 70. Okay, then I add 80 to my queue, is it? Okay, I add 80, front won't change, is it? When you add, front not change, no change, is it? But your back index needed to be updated, is it? It needed to point to the next empty slot, is it? So back should be updated to 2, is it? In this case, updated to 2. Okay, then I add 90, is it? Okay, so 90 is added to the next one, is it? And then similar, your back index should be also updated to 3, is it? So it's going to be updated, is it? Point to the next one, is it? And then you have 100 add. So when you add 100, the back index should be updated to the next empty one, is it? Then I had 110, is it? So after I add 110, I need to update it to the next one, is it? So updated to 5, updated to 5. So back index, just remember, okay, it's point to the empty slot. Okay, to the empty slot. So because it's queue, you have both ends open, is it? And you add at back and remove at front. So you need to keep track of both ends, where front is, where back is it? So that's why over here, we need 2 index, both M front and M back index. Okay, M back index. Okay, so this is regarding the index. And then the next one, let's see. I want to remove, is it? Okay, yeah, please.
So we have M front, right? But Isn't that always will be 0?
Front?
Yes.
Please,
No,
what
once
is
you
your
start
question?
taking stuff off, it changes.
Well,
Because
we have it's an array list, right?
for some reason, my end the voice a little bit of kind of maybe because of bandwidth. Can you repeat the question? It's kind of
I'll take my
broken.
mask off. So, do you hear me right now?
Yeah, yeah,
Okay, so my question is, we have an index m front, which is
yeah.
equal to 0, but since array list, like everything starts with 0, why do we need to index that thing?
You mean the index is the front always going to be
yeah.
0?
I think I can answer this one for you.
That's a very, very good question. Okay, that's why we will see, because right now this scenario we are discussing is a linear array, but we will see there are issues with linear array. So that's why later on we will learn a new concept called circular array. Okay, you will see the beauty of that circular array. Yeah, and that's circular array concept is also a very good technique in computer science. Okay, because some other useful algorithm, they also use that kind of concept. Okay, so very good. Okay, so we will come back to explain. Okay, so now we discussed adding, is it? So now let's see if I want to remove, okay, let's pick this. Okay, so I want to remove 70, is it? After I remove 70, then front should be updated to what? Front shouldn't be point to 0, is it? Your front item is 80, is it? It's 80. So your front needed to be updated to 1, is it? Needed to be updated to 1, is it? And yeah, like what you just put, then should we move 80 to 0, 90 to sub 1, 80 to sub 2, 110 to sub 3? Should we do this?
No, we just can increase the index, which makes sense.
Yeah, you can increase index. Okay, but let's see. There are some other issues, is it? Okay, so now let's see. I want to add 120. And if I add 120 here, then M back will be 6. But your array index doesn't have 6. And you want it to point to an empty slot. So then this won't work, is it? This won't work, but how do we solve the issue? Because the array itself is not full yet, is it? So if we do shifting, is it okay? If we shift, like what I just draw here, is it? If we do shifting, okay, update 80, 90, 100, 110, 120, then that will solve the issue, looks like, is it? But then the issue with this kind of solution is what? Then each time when you remove an item, you need to do shifting. Is it? You need to do the whole array shifting. You need to update the back index also. Is it? So too much shifting. So that's not efficient, is it? Because for this array, the capacity is 6. It's not a big deal. But just think if you have millions of items, that's happened a lot in the real world. Is it application? Is it? Then just think you need to shift millions of times. Is that a good strategy? Of course not, is it? But of course, in the real world, we won't use this kind of like array, okay? But that's just some kind of you can think of something like this. That's not going to be efficient. On the other hand, if you have a small device, electronic device, we call it like IoT, Internet of Things, is it? Thing, is it embedded system? And then in that case, if you have some applications and you cannot just like use some existing framework secure, because those small electronic device, not like of a laptop or a desktop, they have plenty of memory, is it? So the hardware itself very limited. Is in that case, and you may want to implement a queue using array, is it? And you then even that case, you do a lot of shifting, it's not going to be efficient, is it? So this is regarding like some embedded system design, is it? Is it okay? So that's not going to be efficient, is it? So how do we solve the issue, is it? So here we come a new concept. That's a very useful concept called circular array. Okay, so circular, so okay, then let's see, we do this like, I'm going to redraw. And we still have an array, okay? The capacity is 6. 6, okay, so I have sub 0, sub 1, sub 2, sub 3, sub 4, and sub 5. Okay, sub 5. And then let's see this time. Okay, so this time I'm going to add 70. Okay, so I add 70, so front is 0. Is it back? Is also 0. Is it initially? And front and back. Is it both point to sub 0? I add 70. Is it? And after I add 70, my back should update it to sub 1. Is it? This is updated. Okay. Then I add 80. I add 80. What M back should be? So this is our first quiz question. Can you write the answer what M back should be after I add 80? Can you all just send your answer to the chat? M back should be, it shouldn't point to here, is it? It should be here. Is it? So it should be 2. Is it? Okay, then I add 90. Okay, 90, then M back should be what? Should be
3.
3, very good. Yeah, okay, then let's see. 100?
4.
4. Okay.
Good job, Bradley.
110. 110. After I add 110. After I add 100.
It's 5.
Yeah, very good. Is it? It's 5. Okay, now can I add more? No. Okay, stop here. Okay, because, okay, M back. Okay, so the next question is M back should point to the last item or the empty slot beyond the last item. So that's our second quiz question. Where M back should point to. Keep this in mind. Should M back be exactly where the last item is? Or M back should point to the empty slot that's go beyond the last item?
It's the empty spot, right?
Yeah, okay, empty slot beyond the last I. Keep this in mind. Okay, you can send your answer to the chat. This is the second quiz question. Okay, now we will see the beauty. Okay, so now I remove 70.
It just points to 0.
I remove 70. What should I update?
Front and, yeah, just front.
Yeah, you should update front. That's the third quiz question. Third quiz question is after remove 70, what M front should be? Third quiz question. M front should be where? Let me change the color. Okay, it's too messy here. I want to find M front. Yeah. M front updated to 1. Is it updated to 1? Okay. And then I can remove 80. After I remove 80, where M front should be? I can keep removing, is it? After I remove, where?
2.
Yeah, very good. 2. M front. Is it? It's 2. Okay, now let's see. I want to add 120. Where should I add 120? Where do you? Pardon me?
0.
No,
120.
120 should go to 5.
5.
Very
Yeah, 5.
good.
And
And
then
the M back will be 0.
Yes. Is it? I'm back. Updated to 0. Is it? So from 5, drop to 0. Is it? Previously, you see, each time when we do add, when we add, we always increment back. Is it? But now it should drop to 0. Is it? Drop to 0. And also, did you see, in this case, should M back? So if I said M back always greater than M front. So this is our fourth quiz question. Fourth quiz question is M front always greater than M front?
False.
False. Yeah, very good. Is it very obvious? In this case, is it very obvious? Because back is 0, front is 2, is it? So that's not always true. Okay, can I add more? It's kind of messy. Okay, suppose I want to add 130. Where do I add?
to 0.
Yes, very good. 0, is it? Then you update M back to what? M back to 1. Is it? M back to 1. Yeah, so did you see in this case, this is the circular way, is it? In this case, do I need to do shifting?
No.
No. Is it? No shifting. Is it needed? This is very nice. Is it to deal with that shifting issue? Is it? Okay. Then the next question is, how do we I don't want to erase everything, but the Zoom should get a bigger eraser. Oh, this is just, the small one is not efficient. Okay, so okay, let's see. Then, so previously we already get M back to 5, is it? And then it's a drop to 0. Is it drop to 0? So the question here is, so this, when we visualize, we see it's a circular array concept. But the question is, in computer science, how do we represent circular array? Is it, we only have, so in this case, we have that M array. Is it M array? Okay, sub 0 is 70, is it? And then M array. Sub 1 is 80, is it? And we do M array. Sub 4, is it, to 110? That's the first round, what we did, is it? And for the M arrays index, its index range is from 0 to 5, cannot go beyond that, is it? Because otherwise it will cause that runtime exception, array index out of range exception, is it? We don't want that to happen, is it? So now we said, okay, that's the case. We add 110, is it? 110 is then add at M array sub 5 as 110, is it? So then in this case, the back jump to 0. Is it jump back to 0? Is it? So how do we achieve this? Is it initially M back is 5? Is it? So we kind of used to this concept, increment back by 1. Is it? If we increment back by 1, M back should be 6, but array index cannot be 6, is it? But think about like this. If we use module capacity, and this capacity is 6, is it? 6 module 6, we get what? We get 0. Is it? We get 0. Is it? Okay. Then you see it still applies. You can still do plus plus. So because when 5 plus 1 it's 6. But if you do 6 module 6, you bring it to 0. Is it? So back will be automatically bring back to 0. Is it? So here is a new concept. Okay, today's new concept. It's a circular array. So circular array, there is no syntax on circular array. This is purely logical thinking. Logical thinking. Okay, it's just the M back index. Is it? Generally speaking, whenever each time when we do adding, is it? We update back index like this. Is it? But this will cause the issue of index. Cause index out of range. Range issue. Is it? So in order to avoid that, then we can module 6. Is it 6 is the capacity? Okay. Is a capacity. Anyway, okay, 6 is a capacity. And then we won't have this issue. We can solve this issue. Is it? So let's see, just think about it. Is it? And the index range should be 0 to 5. There should be 0 to, but if we apply module 6, so any integer module 6, so this is an integer. Okay, any integer number you module 6, what you will get? You will get 0, 1, 2, 3, 4, 5. You will only have this 6 possibility. Is it when you module 6? Okay, so basically this module operation for index updating is the concept of circular array. Okay, a circular array. So it doesn't matter, even it's 100, even n is 100 or 1 million. The remainder can only be this 6 possibility. Is it? So that's why we call it a circular array. It can wrap around. This concept is very, very useful, okay, in CS. Okay, it's also used in a lot of other places when you learn some algorithm, okay, including some operating system. Okay, some very classical problems. Okay, so this kind of module concept, okay, is very helpful. Help us to do the wraparound. Okay, wraparound, and then you can totally control the number within your specified range. Okay, within your specified range, and everything else basically nothing changed. Is it? And also in this case, even for M front, when we do updating, it's the same. Because each time when we do remove, we also do M front plus 1, is it? But we are going to also let it module capacity, is it? Then you will also control the front index, always be 0, 1, 2, 3, 4, 5. Okay, so you will not have index out of range issue. And at the same time, you also solve the linear arrays shifting issue. Okay, so we get a lot of benefits, is it, with this single operation. Okay, this concept is called circular array. Okay, and okay, that's about this circular array concept. And then let's come back, is it, for our Q. So the Q index, we have front, is it, and we have back, is it, and we also have our array, is it. I suppose in our case it's 6, that we have the array, okay? And the type, assuming we all have integer in this case, okay? Our array, or our Q is an integer Q. Integer Q, okay? Then the array type is also integer, is it also integer? Okay, so with this three instance variables, is it? Then we can take care of our Q data structure, is a Q data structure. Okay, so then each time when we add a new item for the Q, is it? Add a new item to Q, is it? What we need to do is kind of like M array, where you update. You're going to update its back index, is it? But you first assign the new item to that empty slot. This is the empty slot, is it? You're going to add a new item. Add a new item to this empty slot, is it? That's how, and suppose it's equal to that item, is it? But you cannot stop here. You need to next advance. Here we call it advance back index to the next one, is it? To the next empty slot, is it? In a circular way, is it? So how do we do it? It's M back plus 1, is it? That's the next empty one. But because of circular array, is it? We let it module capacity. Is it module capacity? Basically, this is how you're going to add a new item to the queue, is it? Okay, then let's see, how do we remove, is it? When we remove the front item, front item, is it? And we have no way, so M array, is it? M front. This point to the front item. But we have no way to clear this out. Okay, this is different in C and C++. We can explicitly find some way to clear it out, but not for array. Okay, using some other way we can clear it out. Okay, we can clear that memory, but over here we cannot. Is it? So, but your front index is going to be incremented. Is it? But incremented, it can go with the circular way. So if M front, is it, is 5, is it? And when you increment 6, there is no 6. It's jump back, is it, to 0, drop to 0. Is it? How do we do it? It's the same thing. You can do +1, is it, then module capacity. That's how you remove front item. You can guarantee, is it? Even though, you see, if it's 0, front is 0, 0 plus 1, module 6, you still get 1, is it? Yeah, 1 plus 1, you module 6, you get 2, is it? So no matter what the M front is, if you module, you will guarantee it as 0, 1, 2, 3, 4, 5, is it? So it won't cause a problem of out of index, and at the same time it solves the shifting issue, the shifting issue. Okay, so this is regarding how we remove, okay? And in Queue data structure ADT, okay, whenever we say add a new item at back, we generally have a specific word for it, a verb. Just like when you do push to stack, we call it push, is it? Here, generally speaking, we call it in queue. It's a verb, okay? And when you remove item at front, we call it DQ. Okay, it's a verb, okay, DQ. Okay, DQ, remove front. Okay, there is another concept we needed to be clear before we move to how do we do coding, okay, for the queue, is regarding like this circular array, is it? Okay, so this is sub 0, sub 1, sub 2, sub 3, sub 4, sub 5, is it? Initially, when this when your queue is empty, is it? And we can see both M front equals to back. Is it? Equals back. Okay, so then we have 70, 80, then 90, 100, 110. Is it? Then in this case, oh, back is here. Back is here. Is it? And this is considered full. Is it? Now your queue is full. Queue is full. So what is the full condition? Is it? Okay, full condition is when there is only one empty slot between front and back. Is it? We can clearly see it's full. Is it full? Okay, but let's see. Suppose I remove 70, then front is here. Front is 1. Is it? Then I add 120, then back is 0. Is it? But this stack or this queue is still full. You cannot add any more. Is it? So how do we? Yeah, please.
So I guess you mean when there is like when M front is M back plus 1, right? Not that there is another empty slot, right?
So the full condition in circular array implementation, it's there that empty slot should be always between the back item and the front item. That's full.
Okay.
You cannot add. But then how do we express it? Is it? But if you think about it, we do this back plus 1 module capacity equal to front. Is it? So back is 0. 0 plus 1 module 6, you have got 1. Front is also 1. So you see, this is Q full condition with the circular array. Is it? Once again, we use the module operation. Is it? And we can deal with the circular array implementations Q full condition. Then what is empty condition? Is it? So let's see. Right now, okay. So let's just suppose we remove another front item. So then M front updated to 2. Is it? And then I can add another new item, 130. Then back updated to 1. Is it? And back is here, pointed to 1. Is it? Okay, then let's see. I keep removing. After I remove everything, where M front is going to be. M front is also going to be 1. Is it? So when front and back index both are the same, that is Q empty condition. Okay, so this is Q empty condition. Okay, so that's the general idea. Okay, conceptually about all of the ideas regarding